Good morning, guys. So today, let's continue from what we have learned in our previous class. In our previous class, I have formally introduced you the concept called the Laplace transform, the application of it, and the difference between the Laplace transform as well as Fourier transform. And clearly, I have explained you where the Fourier transform will be used, where the Laplace transform will be used. What is the problem with the Fourier transform when we try to apply it with for analyzing a system? And I said clearly that Fourier transform can be usable for analysis of system, but it is having a lot of restrictions actually. And Fourier transform may not be that useful in finding the system's parameters, something like the region of convergence, the value of the location of the poles. This we call it as poles actually. So there are too many restrictions in the Fourier transform, and hence we go for more generalized transform of Fourier transform, that is called as Laplace transform. In short, what I am trying to say is both the Laplace transform as well as Fourier transform does the same job. It just converts the time domain data to frequency domain data. Both does that actually. But there is a difference between a Laplace transform as well as Fourier transform. Laplace transform, it will be including the real part as well for doing the analysis, and hence this plays a crucial role in analyzing the systems actually. This we clearly discussed in our previous class, right? So Fourier transform, in Fourier transform the real part will be equal to 0, so hence s equal to j omega, thereby Laplace transform will be converged into Fourier transform. These things we have already seen in our previous class, and hence Laplace transform plays a crucial role in analyzing the systems actually. These things yesterday also we have discussed. Okay, so இது Laplace transform equation the f of s is equal to minus infinity to infinity f of t e power minus st into dt. So this Laplace transform can be applicable on both sides actually, both positive as well as negative side. So this particular transform I can call it as bilateral transform. If I make this as a 0, then I will be analyzing only on the positive side of the S plane, right? S plane. So hence I can call it as a unilateral. ഒരു സൈഡ് മാത്രം നമ്മൾ അനലൈസ് ചെയ്യാൻ പറ്റുമെങ്കിൽ that kind of Laplace transform I call it as unilateral transform. ഇത് ഇവിടെ 0 വരും. ഓക്കെ അല്ലേ? മൈനസ് ഇൻഫിനിറ്റി ഇൻഫിനിറ്റി മീൻസ് ബോത്ത് സൈഡ്സ് ആണ്, രണ്ട് സൈഡിലും അനലൈസ് ചെയ്യാൻ പറ്റും. സോ ഈ എസ് പ്ലെയിൻ എന്ന് പറയുന്നത് ഇറ്റ്സ് നത്തിങ് ബട്ട് ഫ്രീക്വൻസി പ്ലെയിൻ ആണ് അഗൈൻ. ബട്ട് Fourier transform will be having only j omega, but here we are having both sigma as j omega. Okay, both real part as well as imaginary part here. So that is the basic difference actually. So unilateral transform will be useful on certain cases where we need to concentrate on the positive side only, and in case if you need a broad spectrum, then we have to go for the bilateral transform. These things already we have seen, so let us move on to the next thing. Look, check out the particular equation. That equation of the Laplace transform strictly depends upon this value, that is the integration of something, right? Integration of f of t into e power minus st into dt. Since it depends upon this particular factor integration, very sure integration may or may not exist on certain conditions actually. So what I'm trying to say is this integration should give me the real part of the integration. The integration of the real part, okay, the integration of the real part of this factor should be lesser than infinite. Then only this particular integration will be, I can call it as absolutely integrable. If only it is absolutely integrable, then only I can say that my Laplace transform exists. Very, very important statements actually. I will repeat the sentence. What I am trying to say is, this particular equation is governed by the integration operation, and integration the formal definition ഉണ്ടല്ലോ. ഞാൻ ആക്ച്വലി ന്യൂ ആയിട്ട് ഒന്നും പറഞ്ഞല്ല. Integration, if it has to exist, then the real part of ഇതുണ്ടല്ലോ f of t e power minus st into ഇതിന്റെ real part, ഇതിന്റെ real part എന്ന് പറയുന്നത് എന്താ? f of t into e power minus sigma t into dt അല്ലേ? ഇതാണ് ഇതിന്റെ absolute integral എടുത്ത് നോക്ക്. it should be lesser than infinite. This is the condition. If it is lesser than infinite, then we can say that the particular factor is integrable or absolutely integrable. If the given factor f of t or else any system, if it is absolutely integrable, then I can say that Laplace transform exists there. Lesser than infinite ആയാൽ മാത്രമേ integration എടുക്കാൻ പറ്റൂ. Integration എടുക്കാൻ പറ്റുമെങ്കിൽ then we can say that Laplace transform exists. If not, Laplace transform does not exist there. അപ്പോൾ Laplace transform എന്ന് പറയുന്നത് ഒരു conditional transform ആണ്. എല്ലാ സ്ഥലത്തിലും Laplace transform എടുക്കാൻ പറ്റുമോ എന്ന് ചോദിച്ചാൽ ഇല്ല. എല്ലാ സ്ഥലത്തിലും Laplace transform എടുക്കാൻ പറ്റില്ല. Laplace transform only if you can take an integration, only if it is absolutely integrable, then only that particular given factor or also the particular given function Laplace transform exists. Otherwise, no. Okay. So that's one point actually. And what else? So as I said, f of t, the absolute integrable e power minus sigma t dt should be lesser than infinite. So how, I mean, if this has to be lesser than infinite, very sure we are talking about this only, very sure, because it's an exponential series. And say for example, if sigma is lesser than 0 on this particular case, then what happens? The whole exponential becomes positive actually. So that means this is an exponentially growing series. If it is exponentially growing series, the integration may not be the integration is not absolutely integrable because it will violate this condition. So if it is sigma is greater than 0 for this particular case, sigma is greater than 0, then that particular term, exponential term, will be again in a negative form. Then only at this particular condition, only for this particular condition, the integration exists because it is absolutely integrable, and hence I can conclude that Laplace transform exists for this condition, something like that, right? So it depends upon the problem which we are doing actually. So based on the particular problem, these conditions may change actually, right? So the Laplace transform typically depends upon this factor, sigma, right? So let's try to move on. I mean, maybe we can understand this and we can appreciate this by looking into a problem. We will appreciate this one more after looking into a problem. Find region of convergence of f of t is equal to e power 2t u of t. What is region of convergence? Region of convergence is a place where the Laplace transform exists. That is absolutely integrable. So region of convergence means എവിടെയാണ് ഏത് കണ്ടീഷനിലാണ് ലാപ്ലാസ് ട്രാൻസ്ഫോം എക്സിസ്റ്റ് ആവുന്നത് അങ്ങനെ കണ്ടുപിടിക്കാനുള്ള ഒരു ഏരിയ ആണ്. Okay, so let's try to understand this by doing a problem. So let's try to find the region of convergence of this particular given system. So as I said, Laplace transform exists for this condition. This the modulus of this one should be lesser than infinite. Should be lesser than infinite. So how we can write that? Minus infinity to infinity. What is f of t here? E power 2t u of t e power minus sigma t dt This factor should be lesser than infinite, and just applying the value of this is a unit step function, right? Unit step function means it exists only on the positive side. For the given equation exists on the positive side, that is from 0 to infinite. Hence the limit will also be changed. So 0 to infinite e power 2t u of t will vanish because the value is 1 into e power minus sigma t dt. So again this can be written as 0 to infinite e power 2 minus sigma t dt, and as I told, this should be lesser than infinite. And clearly this can be lesser than infinite if only 2 minus sigma is lesser than 0. Why? Because lesser than 0 means a plot നമ്മൾ വരച്ചു നോക്കിയാൽ somehow it will be dropping, so absolutely integrable ആണ്. Hence, okay, if it is greater than 0, then it will be swelling, actually exponentially growing wave ആണ്. ഇത് infinite ആയി പോകും. അപ്പോൾ ഇൻഫിനിറ്റ് ആവുമ്പോൾ ഉറപ്പായിട്ട് ഇന്റഗ്രേഷൻ എടുക്കാൻ പറ്റില്ല, എല്ലാ സ്ഥലങ്ങളിലും ഇന്റഗ്രേഷൻ എടുക്കാൻ പറ്റില്ല. That's why we avoid that particular condition. That's why we prefer this particular condition, right? Because here only the system will converge. Here only we can expect the integration to provide us a result, actually. So this is the place where the system can be operable, something like that. I will explain that later on. So what about this one? Sigma, I can rewrite like this one. Sigma is greater than 2. So in short, what I can say is this S plane is a rectangular plane, actually. So once after conversion from time domain to S plane, we find that system is convergible, or a system can be workable, or else a Laplace transform exists. Say for example this is 2, only on this particular plane. Appo ee sthalatthil system will not converge. Laplace transform does not exist. Okay le, appo sigma is greater than 2 nu parayana is triple matram till infinite. Okay, is area full light. That means let me show it. So if sigma greater than 2, ഇത് 2 ആണ്. ഇതിന്റെ മുകളിൽ എവിടെ പോയാലും സിസ്റ്റം കൺവേർജ് ആവും. So the Laplace transform exists everywhere here, but here it does not exist. So ഇതിന്റെ പ്രാക്ടിക്കൽ മീനിങ് ഒന്ന് പഠിച്ചു നോക്ക്, ഒന്ന് ആലോചിച്ച് നോക്ക്. കൺട്രോൾ സിസ്റ്റം നിങ്ങൾ പഠിച്ചിരിക്കും. കൺട്രോൾ സിസ്റ്റം അതിൽ എവിടെയെങ്കിലും ഇത് അപ്ലൈ ആവുന്നുണ്ടോ? അതിൽ നിങ്ങൾ ഇത് ലൈക്ക്, so can you link the thing what we have studied now with any of the concepts what we have studied in control system? Just one ആലോചിച്ച് നോക്ക്. We will discuss about this later on, but very very important discussion that so that will be. So I want you to think about this, actually. I want you to come up with an answer. I will repeat the question. Do you have any link with the subject control system with respect to this particular topic, region of convergence? അപ്പോൾ ലാപ്ലാസ് ട്രാൻസ്ഫോമിൻ്റെ അപ്ലിക്കേഷൻ കൺട്രോൾ സിസ്റ്റത്തിൽ എങ്ങനെയാണ് പറയുന്നത്? ഈ സിസ്റ്റം ഡിസൈനും ഇതിനും തമ്മിൽ ഏതെങ്കിലും ലിങ്ക് ഉണ്ടോ? ഏതെങ്കിലും ഒരു ചെറിയ ഒരു ലിങ്ക് ഉണ്ടോ? പോൾസ് എന്ന് പറയണത് എന്താ, സീറോസ് എന്ന് പറയണത് എന്താ, ഇതൊക്കെ നിങ്ങൾ ഒന്ന് ആലോചിക്കണം. നിങ്ങൾ തന്നെ ആലോചിക്കണം. ഐ വിൽ ഡിസ്കസ് ദാറ്റ് ലേറ്റർ ഓൺ. Let's try to solve one more problem to have more clarity on this, because we are discussing a new topic. So let's try to do one more problem. Let f of t is equal to e power minus at ut. Okay, so I have been asked to find the Laplace transform for this one. Laplace transform of this one can be written as minus infinity to infinity f of t e power minus st into dt. What is f of t? F of t is this one. So after applying this on u of t, as I told, exists on the positive side, so this becomes 0 to infinite e power minus at, this will vanish because it's 1, u of t is equal to 1 minus e power minus at into e power minus st into dt. This I can write like 0 to infinite e power I hope you understand this particular step. Simply I am rearranging things actually. So finally I have to take the integration. After taking the integration, my equation will be looking something like this. So I have to apply the limits, right? So this will be equal to 1 by s plus a, 1 by s plus a, right? So here I am very interested about this equation. As I told earlier, the we have to find, we have to find whether the particular integration operation is absolutely integrable or not. Then only we can conclude the Laplace transform exists, right? So this particular equation will reveal me a lot of things actually, because as I told earlier, the this one sigma is equal to, sorry, s is equal to sigma plus j omega le. Upon the positive side of this one, e power minus sigma, positive side on, because magnitude we are talking about modulus, right? So we are not worried about this one, we are worried about only this one, minus sigma plus a t dt. This should be lesser than infinite. So how this will be lesser than infinite? If only that sigma plus a is greater than 0. Alright, if it is lesser than 0, this will become a positive thing, and that will violate this condition. So sigma plus a is, if sigma plus a, if it is greater than 0, then I can say that particular condition, the particular given equation is absolutely integrable, hence Laplace transform exists. So we have a strip like this. This is a minus a region. So this is S plane. So for this particular condition, this particular condition holds true, and hence our actual given function is absolutely integrable for only this condition. Okay, so that means sigma is greater than minus ALA. അപ്പോൾ സിഗ്മ ഈ ഏരിയ ഉണ്ടാവും, മൊത്ത ഏരിയ ആവും. ഈ മൊത്ത ഏരിയയിലും ലാപ്ലേസ് ട്രാൻസ്ഫോം എക്സിസ്റ്റ്. Or else I can say that the given system is converging, or else we can say the system is stable. ഞാൻ ഫസ്റ്റ് ചോദിച്ച ചോദ്യത്തിന് ആൻസർ ഇപ്പോൾ തന്നെ ഞാൻ പറഞ്ഞു, പക്ഷേ നിങ്ങളൊന്ന് ആലോചിക്കണം എന്തൊക്കെയാണ് ഞാൻ മീൻ ചെയ്തതിന്. അത് വലിയ കാര്യങ്ങളാണ്. Control system പഠിക്കണം. You should be able to connect the subjects actually, then only you will be smarter. Okay, so system is converging on this particular area, that means the system is stable on this particular area. Okay, അപ്പോൾ control systemത്തിൽ നിങ്ങൾ ഡിസൈൻ്റെ കാര്യമൊക്കെ പഠിക്കുമ്പോൾ what if the system is unstable എന്നൊരു കാര്യമുണ്ട്. ഓക്കെ, ഞാൻ തന്നെ ആൻസർ പറഞ്ഞു, പക്ഷേ ബാക്കിയുള്ളത് ചെറിയതായിട്ട് ചെറിയ കാര്യങ്ങളുണ്ട്, അത് നിങ്ങൾ നോക്ക്. ഓക്കെ അല്ലേ? വാട്ട് ഇഫ് ദ സിസ്റ്റം ഇസ് അൺസ്റ്റേബിൾ, വാട്ട് ഐ ക്യാൻ ഡു അബൌട്ട് ഇറ്റ്. ഓക്കെ, അതിനെ ഇപ്പോൾ സംസാരിക്കണമല്ല, ബിക്കോസ് അത് കൺഫ്യൂഷൻ ആവും. അപ്പോൾ നമ്മളുടെ കാര്യം ഇത് മാത്രമേ ഉള്ളൂ. വേർ ദ സിസ്റ്റം ഇസ് ഇന്റഗ്രബിൾ, വേർ ദ സിസ്റ്റം ഇസ് കൺവേർജിങ്, ഇത് മാത്രമാണ് നമ്മളുടെ ചോദ്യം. അപ്പോൾ നമ്മളിപ്പോൾ ആൻസർ ചെയ്തിട്ടുണ്ട്. ഓക്കെ അല്ലേ? പിന്നെ വേറൊരു കാര്യം കൂടെ, ഇതൊന്ന് നോക്കിയോ മോളിൽ, ഇത് ഇവിടെ വെച്ച് വായിക്കാം. ഈ പാർട്ടില് ഒന്ന് ആലോചിച്ച് നോക്ക്. ഇഫ് എ ഇസ് ഗ്രേറ്റർ ദാൻ 0, then system will be converging. Like if a is lesser than 0, exponentially growing, so it's not absolutely integrable. It's not absolutely integrable. So system may not, I mean, Laplace transform does not exist here. Laplace transform does not exist here. So in short, what I can say is the given system has a region of convergence, of sigma greater than minus a. This is the answer for it. Okay, so we have been given a problem and we have been asked to analyze actually. So we have analyzed using Laplace transform, and finally we have found that for sigma greater than minus a, our sigma greater than minus a, our system is converging. Okay, so let's try to do a lot of problems so that we can understand more. Thank you very much.